Okay, this is going to be a quick demo of how to get started with the final project option 1. This is the converter. We're going to convert binary to decimal, decimal to binary, hex to decimal, and decimal to hex. Okay, so I've started you out with a little bit of help here in this file. You don't have to use this file, but this is for people who need a little bit of extra structure getting started. So for binary to decimal, we're going to create a loop, and it takes this argument bin, bin, for a binary number that's either going to be, it's just going to be a bunch of ones and zeros. Okay, so what we're going to do is make a for loop that looks at the first character, and if it's a 1, that means we need to multiply by 2 to this power. So remember, in base number systems, each place has a value. This is the ones place. Okay. Here, this is in binary. This is the twos place. This is the fours place. Okay, so we need to figure out what power this is, right? So for the number 110 in binary, that's going to be, we have a 1 there, so it's 1 times 2 to the what power? Well, this is the ones place, which is 0. This is the twos place, which is the 1 power, and this is the fours place, which is the second power. Okay. So the next position is 1 times 2 to the what power? It's 1 less than that, right? It's the ones place. And then this is a 0 times, which it doesn't matter what we multiply because 0 is going to make this whole thing 0, but it's 2 times 2 to the 0 power, which is 1. Okay, so the important thing to remember here is whatever position we're in, we can determine the power based on the length of the string. Okay, so the length of the string here was 3, and so the first power was 2. If the length of the string is 4, then the first power is going to be 3. Okay, so you can write that in code however you need to, but you're going to have to do something like, power, the power you're going to raise it to is going to equal, bin length and it's going to relate to your index too. So the first time index is 0, so I equals 0. So if I equals 0, 1, 2, 3, so if I equals 3, and we want to find this power, right, this should be 0, because this is 2 to the 0. So our power should be the length of the string, and then we subtract I, okay, so I is 3, so that would give us length of the string is 4, so 4 minus 3 is 1, but we need 0, right? So we subtract 1 more. That's essentially going to give you your power. And so all of these would be 2 to power. As you go through the loop, power is going to be this, and each time you go through the loop you're going to add the digit, if it's a 1 or a 0, times 2 and calculate that power. Okay. So basically here you make the loop, and inside the loop you're going to have power equals what we just set up there. We're going to have that variable power, and we're going to add to our number num plus equals, which is the same as equals whatever it did before plus more. And the thing we're adding is the digit times 2 to the power. And you just go through and do that through the loop and then return number. Okay, so digit needs to be a number because we're doing math. So you make sure if the digit is a string 0, you make sure digit is the number 0 when you multiply. If the digit is the string 1, if the character in this binary string is a string, if it's the string 1, then digit here has to be a 1. Okay. So decimal to binary, you basically create a while loop that runs while your number here, this is a decimal number, is greater than 0. Okay. So we go through, and first thing we can do, which is a quicker way of converting decimal numbers to binary numbers, is let's divide by the number 2, and the remainder will tell us our units place. Okay, so let's say if we have the number, let's see, so 16 is even, right? So if we divide by 2, that's a 0, a remainder of 0. It divides evenly. Okay, so we know a binary number is even if this units place is 0, and it's odd if it's a 1. Okay, because if you there's no other way for you to have an even number, because this is the units place is just 0 or 1. So if it's a 1, it's automatically an odd number, because this is the tens place, or the twos place rather, 2 to the first power. So that would be 1 2, that would be 0 4s, and 1 8. So this number is 8 plus 0 4s plus 1 2, so that's 10, plus 1 1 is 11. So this number at the end is always going to determine whether it's even or odd. So what we're going to do here is we have a number and we divide by our base. Our base is 2. The remainder is going to give us the position, the rightmost position of our number. So take the number 17 for example. If I take 17 and divide it by 2, I need to get the remainder. You get the remainder with modulus. Okay, so 17 divided by 2, 16 divided by 2 is 8, and there's a remainder of 1. Okay, so that means our binary string should at this point have a 1 in it. So we add a 1 at the very rightmost position. Next we're going to focus on this position. Okay, so we change our number from 17, we divided that by 2, our base, and got the remainder, and that's the value here. Now we divide by 2, and we don't get the remainder, we just get the division. So this is going to be number divided by 2, and if we take the math.floor of that, it removes the decimals. Okay, so 17, basically, it's like we removed this remainder part. We subtracted the remainder from this. The remainder was 1, so now we want 16, and then we divide 16 by 2, and that's 8. So that's our new number. So now we're at 8. Okay, now we go through the loop and we say 8 modulus 2. What's the remainder when you divide 8 by 2? It's nothing. It divides evenly. Okay, so the remainder is 0. So that's what we put in here, 0. Okay, and then we do the actual division and take the math.floor of it. So we got 8, our number now equals 8 divided by our base, and then we take the math dot, oops, math.floor, which is going to eliminate the decimal part. It's going to truncate it. It's going to take the decimal part off and just make it 0. Okay, so this is 8 divided by 2. The floor of that is 4. Okay, so our new number is 4. Okay, we're going to take the remainder when we divide by our base. Number divided by our base, it divides evenly, it's a 0, so that means we put a 0 here. Okay. Then we actually set number equal to math.floor of number divided by 2. So our number is 4, so we divide number by 2, and that's 2. And we do it again. So now number equals 2. So what is number, the remainder when we divide by our base? 2 divided by 2. The remainder is 0, so that's what goes here. Alright, so now we take number and set it equal to math.floor of number divided by base. Okay, so 2 divided by 2 is 1. Alright, so we start the loop again. Number equals 1. Number modulus our base, which is 2. We divide by, the number is 1, so 1 divided by 2 has a remainder of 1. That's what goes here. Okay? And then you set num equal to math.floor of number divided by our base. 1 divided by 2 is 0.5. The floor of that is 0. So our while loop needs to exit now. So our while loop has to say, while our number is greater than 0, we keep going. As soon as our number is 0, we have to quit. And if you look here, we started with the number 17. Okay, so what do we have here? We have 1 1, 0 2s, 0 4s, 0 8s, and 1 16. 16 plus 1 is 17. Okay, so that's all you need to do, but you need to do it in a loop. And this is the exact same for decimal to hex. Okay, the only difference is our base is different. Our base is 16. Okay, and so when you need to figure out what number to put in the string, you're not putting a 0 or a 1. So here's a little array. When you get your remainder, is our number modulo our base, which is 16. The digit that goes in here, our hex string digit, is going to be take this array, whatever number we get here, it's going to be 0 through 15. The index of this character is 0, 1, 2, 3, 4, all the way here. Where it gets important is 10, because we can't just add the number 10 to our hex string because we need the number, or the character A. So here we take our remainder. Our hex string is going to equal decimal character to hex, that array, at index, remainder, and then add whatever the rest hex already was. This is no different than in the other one when we did bin equals 1 plus whatever bin equaled before. So this was the remainder. Okay, but we didn't have to convert it to a character because it was just 0 or 1, and JavaScript would already convert that to a string for us. But in hex, our remainder can be 10, and we don't want to add the string 1 0 because that means something completely different in hex. We want to add the character A for 10. Okay, so that's the main difference there. But other than that, it's just like decimal to binary, dec to bin up there. Okay, and then the last one is hexadecimal, hex to decimal. Alright, so you've got this little object here. This is going to be a string of hexadecimal characters. Okay, those are all valid hex characters. I can have 0, 1, anything 0 through 9, and then A through F. Okay, it's just like binary to decimal, except each time we get a character, it's not a 0 or a 1, so we have to convert what that character means. That gets important again when you get to the letter A. That means decimal 10. The letter B means decimal 12. Okay, so that should get you started on that one.